So in this case, we are going to quickly consider our question number 6, which is given on 6.1. We are given the information that is two or more pulses can pass through the same medium at the same time in the same place. When they do, they interact with each other to form a different disturbance at that point, right? Which is very true. That is what we know when a disturbance happens when you're considering a pulse, a transverse pulse. The resulting pulse is obtained by using the principle of superposition. State the principle of pulses. That was the question here, this one. All this information is that do you actually understand you are referring to? What is it that you refer? The superposition of pulses. When two pulses meet each other to create larger pulse. That is when a crest meets another crest. So there is an addition that is happening there. Differing, we're going to see at the end how they differ. So the principle of superposition, we can simply refer it as it states that when two disturbances occupy the same space at the same time, the resulting disturbance is the sum, which is the addition of two disturbances. All right? Which is the sum, that is the addition. You have to add to combine them. All right? So remember, we can have a constructive interference or we can have a destructive interference depending with what you're having, with what you're given. So in this case, we are given 6.2, destructive interference, take note, takes place when two pulses meet and result in a smaller amplitude disturbance. All right. Remember, the constructive is the one that will give us a bigger at the end after the interference. We are at the interference like this one. We are going to have something bigger at the when they interfere. That is when it is a constructive, but for a destructive, that is something else. We are going to have a difference, right? When we add whatever that you're going to have, it is going to be smaller. Whatever that you're going to have, is it on top or is it a throw like that? It is going to be smaller. That is the condition. We are supposed to know this one because they can even ask you to describe that. Okay. So the amplitude of the resulting pulse is the sum of the amplitudes, which is fine, of the two initial pulses. But one amplitude will be a negative number. This is exactly what the destructive interference is all about. It's like a description that they are giving us. Like I said, they can ask you this description, so do not just take it for granted. You're supposed to know this. So our question is here. That is our question, that use the theory of destructive interference, which is this part, to draw two pulses of different amplitudes meeting from different directions to demonstrate this theory. How best can we demonstrate the destructive interference? So we can have these diagrams, depending on what you want. You can use this condition or you can use this condition when we have an interference that is happening when pulses move towards each other, as we are considering that it takes a place when two pulses meet and results in a pulse of reduced amplitude at the end. This one is reduced compared to what we had before. All right. So we are going to have, in this case, that is a crest to, and also we have got a throw on this part. So a crest is moving to the right side, a throw is going to the what? to the left side, depending with the information that you are given. But as you can see, this one will be positive and this one will be negative. So they just know your diagrams, guys. And this is the condition when the interference happens, the destructive interference. It is going to give us something that is smaller than what we had before. If this one is a 6 and this one is a 2 like this, it will be in the negative region. So at the end, you'll be having 6 plus minus 2, which will give us what? A 4. So as you can see, 4 will be smaller than what you had before. So that is the condition of a destructive. You end up with a smaller amplitude. Then after that interference, what we had, if this is A, if this is B, B is going to move, continue to the side where it was going. So B will end up this side. A will end up to the what? To the right side, because it was moving to the right side like that, with their original amplitudes maintained, meaning say this one for B will remain as it is. This amplitude for A will remain as it is, all right? So I think this one can be best to present what your question was all about. Remember, they just wanted you to use the diagrams to demonstrate the destructive interference. So you can just consider this way, or just a simpler presentation. Some of us, we just need those simpler presentations. Some of us can present it this way. Just our axis, which is from the position of rest. Then we're gonna have something of this nature where we have got the crest and the part of the trough. So moving to the left and this one moving to the right. Then as we can see, this side is bigger. So meaning to say our resultant when they meet is going to be on top, but smaller than what it was like here. All right, that is the condition. So guys, you can just put it this way. Just a simpler presentation, you obtain the 3 marks. 6.3, we're given a pulse covers 37.5 centimeters, which is the distance. So we're given the distance in this time on a heavy rope. Calculate the pulse speed in meters per second. So guys, this is a direct question where you need to calculate the speed given distance and time. Remember, I say that the speed can be calculated when given distance and time. You can simply use distance over time. You can just consider that one is distance. But this distance is supposed to be in meters, this time in seconds, so that we obtain what? Meters per second. We are supposed to have these units. So if we are to consider according to the information, our distance is what? 37.5 in centimeters. We're supposed to convert it to what? To meters. Divide by 100. Remember, in a meter, we've got 100 centimeters. So that was going to give us 0.375 in meters. Having this distance in meters, we're going to substitute here. So therefore, our speed was going to be 0.375, which is in meters. All right. Over the time, as we can see, our time is already in seconds. So the time frame, that's 1.25 in seconds. So that is it, guys. When this is in meters and this is in seconds, definitely we shall have meters per second. So that was going to give us 0.3 meters per second. So that's it. Just like that. So questions can be of this nature. Just a simpler question like this. So let's do revise questions, both our theory, presentation of diagrams, calculations at the same time. Let us just try to balance as we are having our revisions. It is going to be a little bit more, but as we do more question papers, you will see that it is just a repetition, like I said before. So that's it, guys. Till we meet again.